Another application of atmospheric pressure is in the lift pump. A lift pump could also be called a common pump, or you could call it a borehole. So let us look at how does atmospheric pressure help in the operation of the lift pump. So the lift pump, in a lift pump, atmospheric pressure always helps to push the water through the pipes. So in a lift pump, atmospheric pressure helps to push water through the pipes, as this writing reads. Now, how does a lift pump look like? So here we have the lift pump. Now you realize that this diagram and this one, they are just the same. The only difference here is the movement of the piston. This is what we call the piston, this one, which is the same as this. So when the piston moves upwards and when the piston moves downwards. When the piston moves upwards, we call that the upstroke. And when the piston moves downward, that is the downstroke. So we are going to see what happens during the upstroke and then the downstroke. Now briefly, we have two valves. There are key things you need to know about the lift pump. You have the handle, which helps in moving the piston up or down. Then we have two valves. One is the A, B. You see, this is the upper one we have called A, the down one is B. So one interesting thing about these valves is that when one is open, one closes. So we shall see when does A close, when does B close, and when does A open and B open. So here you have the barrel inside. Here this is the barrel, and inside there is water. Now let us see atmospheric pressure. This is now our well down here. This first diagram shows the upstroke. That is when the piston moves what? Up. And then this diagram shows the downstroke, when the piston moves down. So let us see what happens during the upstroke. Now during the upstroke, this is when the piston is moving up. When this piston moves up, it creates more space here. So the pressure here inside the barrel, the pressure reduces. And when the pressure reduces, it means the outside pressure. You see these arrows? That is atmospheric pressure, because this water is open to atmospheric pressure. So the atmospheric pressure will be pressing it down. And when it presses it down, what happens during the upstroke? The water enters. This water comes with pressure, so it will hit this valve and the valve opens, and then the water will find itself up. But before that, when you are to begin using a lift pump, some water is always poured on top of the piston. This is the piston, this is the piston, and this is the top. So some water is always poured on top of the piston to avoid the air leaking past the piston. So after a few strokes, the pump is now lifted with the water as a result of the following. So there is always some water which is poured on top of this piston to avoid air leakage past the piston. So what always happens is that when you make a few strokes, the pump will always be full with what? Or be filled with water because of the following. So let us see how a lift pump. We have already looked at the diagram during the upstroke and the downstroke. Maybe just to explain a bit. During the downstroke, you see, this is when the piston is moving downwards. So what happens? This water is going to be pushed downwards. And when it is pushed downwards, because of the weight of the water, the pressure from the plunger and the water will press this, and this valve will what? Close. When this one closes, this one what? Opens. And when this one opens, it means water is now free to go up. You see? So the water now goes up. So that is what happens during the downstroke. Okay. So we have the piston, we have the spout where the water is supposed to be pouring from, we have the valves, okay, we have the handle, and then we have what we call the barrel. Then here the pipes are going down inside the water in the well. So we are saying, how does this thing work? How does it work? Okay. To begin using the lift pump, water is poured on top of the piston to avoid air leaking past it. So this one I already said. After a few strokes, the pump is filled with water as a result of the following actions. In the upper stroke, valve A opens, pressure in the barrel reduces below the piston. So valve A closes. Then pressure in the barrel, inside the barrel, reduces. You know, inside the barrel, when we say inside the barrel, the whole of this is the barrel. So where is the pressure reducing? Is it on top of the piston, above the piston, or below the piston? The pressure reduces below the piston. As you lift this one up, this one now goes up. More space is created. So the pressure here reduces below the barrel. You see? So the pressure below the barrel. So we are saying valve A during the upper stroke, valve A closes, pressure in the barrel reduces. Which pressure is that one? Below the piston. So that one gives the opportunity to atmospheric pressure being greater now because the pressure inside has reduced. So atmospheric pressure acting on the surface of the water pushes the water up through valve B. Why through valve B? Because valve B is open, but valve A is the one which is what? Closed. Also, water on top of the piston is lifted upwards and flows out of the spout, you see. So before you lifted this during the upstroke, before the piston went up, there was already some water passed on top here, some little water. This is the water we are saying that before you begin using the lift pump, some water is poured on top of the piston. So on top of the piston here, there was already some little water. So as you lift this one up, the pressure here inside the barrel, but below the what? Below the piston, this area reduces. And when it reduces, the atmospheric pressure becomes greater than the pressure inside. It presses this, then this water enters. Now that water, as it enters, it comes with the pressure. It's going to hit this. That pressure is going to force this valve to what? To open, you see? And then the water rises. Then the water which was already, the one which was already on top of the piston, as this thing moves up, is also going to be lifted up. And as it is lifted up, it is going to pour through the what? The spout. So that's what we are saying. That valve A closes, pressure in the barrel below the piston reduces, atmospheric pressure acting on the surface of the water pushes the water through valve B. Okay? Then the water which was already on top of the piston is lifted up. And once it is lifted up, it flows out of the spout. So that is what happens during the upstroke. What about the downstroke? Now in the downstroke, the valve which was open will now be closed. Remember, in the upper stroke, valve A was closed, so it now opens. Okay, that is valve A. Then B, which was open, closes. So during the downstroke, valve B closes by the pressure of the water on it, and valve A opens. And once valve A opens, it allows water to pass upwards into the barrel above the pump. You see? So this is what we are saying. Back to the diagram, that during the downstroke, what happens? This valve now opens and this one closes. Why does this one close? Because when this one moves, when the piston moves downwards, there's some pressure which water is going to exert on this valve. So it will make the weight of the water, it will make this valve to close. Meanwhile, this one will open. And once this one opens, the water now will go past. It will go now on top. You see? So by the time again you bring the upper stroke, there is already some water here waiting to be lifted up to pour. So briefly, this is how the lift pump works. So if somebody asks you a question like this exercise A, that with the aid of a labeled diagram, explain how a lift pump works. How will you score? You see, in the downstroke, valve B closing, pressure on the water on it, valve A opening. You see where the ticks are? This is how somebody will award you marks. You see, valve A closes, pressure in the what? In the barrel reduces, so you can see this how you get your marks. And by doing this, you be sure that you will get all your marks. You see, drawing a diagram and labeling, you also get your marks. You see, so one for drawing, one for labeling, and then explanation during the upper stroke what happens, then during the down stroke what happens. Now let us look at also the siphon. Now the siphon is very easy. This is the tank. Maybe you have your oil here. This is a liquid, but you want this oil, you want this tank to become empty. You want to empty the tank. All this liquid, you want it to flow somewhere. Maybe you are transferring petrol from a tank somewhere. So what do? You use, you see, this connection from here, the way you see my hand moving up to here. This is what we call the siphon. Now a siphon is in such a way that one side is shorter, it has a shorter arm, and then the other arm is long. There are two arms here, XW or WX, then there's another arm which is YZ. So you see, one side is longer. So this arm is longer, then this one is shorter. The shorter arm is always put inside the what? The liquid which you want to flow. You see, to make this tank empty, such that this liquid is no longer there, it will take you a lot of time. But if you use a siphon can help you. So what you do, you simply get the shorter arm, put inside the tank of the liquid, and then the longer arm will be outside. So when you want to start it, you want it to start working, you come on this side, then you try to what? To pull. You pull the liquid by sucking downwards, and when you suck, of course this liquid will begin flowing. Now once the liquid becomes full, once the siphon becomes filled with the liquid up to here, then you stop pulling. And once you stop pulling, what happens? The liquid begins flowing by itself. So the liquid continues to flow as long as this end is below the liquid level in the tank. You see, as long as this end is below, this side is below, the tank is raised, then this end is down. This liquid will continue flowing until the tank becomes what? Empty. Now the question is, what makes the liquid to flow? The liquid flows because of the greater force of gravity. You see, there is a gravitational force, which is pulling this liquid downward. So here there is a gravitational force, there is also gravitational force. There is gravitational force on this arm, the short arm, then there is also gravitational force on the longer arm. But the gravitational force on the longer arm is greater than, you'll see, there is more on this side. The force of gravity becomes greater on this side than on this side. So this makes the liquid to flow. So as I already explained, you have the shorter arm, XW or WX. You have the tank. This is the tank which is containing the liquid. Then this is the liquid. So we are saying, to start a siphon, if you want the siphon to start working, it is first filled with the liquid, you see. So you pull this liquid from here so that the whole siphon is now full of the liquid. To start a siphon, I said it is first filled with the liquid, okay? Then after, the liquid continues by itself to flow out as long as the end Z is below the liquid level in the tank. So the liquid flows because of the greater force of gravity on the column YZ. That column, that arm YZ is longer, so the force of gravity will be more there, which pulls the shorter arm WX, Because Wx is what? Short, the other one is long, so the longer one will be pulling. The force of gravity on the other side will be greater. So which pulls, the longer arm will be pulling the shorter arm through cohesion between the molecules. Cohesion is a force of attraction between molecules of the same substance. So as the liquid flows, you find that each molecule of the liquid is attracting the other one. Each one is attracting the other one. So there is going to be cohesion between the liquid molecules, which will be greater due to the force of gravity. So this is how a siphon works. Where do we use siphons? Where do we use siphons? Uses of siphons: 1, to remove water from a fish aquaria. You see, if you want a fish pond to dry, you want to remove the water from a certain fish pond, an aquaria, you can use a siphon. To empty a petrol tank which is full or filled with petrol. So if you have your petrol tank and you want it to you want the fuel, you want the tank to remain empty, what do? You can also use a siphon. NB, siphons can work in a vacuum. So a siphon can work in a place without air.